All right, this video is for the lesson 1.4 homework, complex numbers, college algebra for 2024. All right, so complex numbers. What's number one?
The imaginary unit I is defined as I equal blank, or I squared equals blank.
So you said I equals. So I equals the square root of -1. I squared is -1. And the reason that works, if we would take the square root of -1 and square it, it cancels itself out. All right, number two.
The set of all numbers in the form of a plus bi is called the set of blank numbers.
It's imaginary or complex? I think it's complex.
Complex, yeah.
If b does not equal 0, then the number is also called a blank number.
Okay, wait. If b does not equal 0, so what's the format again? A plus bi?
This one.
A plus bi. So complex, this was complex, right?
Yes.
So if b doesn't equal 0, well, if b equals 0, then it's not even a complex number. It's just a rational number or an irrational.
Yeah, that's
Or
the-
imaginary, complex, or real.
If b equals 0, it's a real number.
So then it
Yeah,
must be
which is
imaginary, 'cause
the
that's the
next.
next
Okay, so if b doesn't equal 0, I would say
imaginary.
imaginary. Somebody else check it if you've got two checks on it. Imaginary.
All three?
So the first one?
So complex, imaginary, and real.
So if b equals 0, is that what the next one is?
Yes. The
Okay.
number is also called a blank number.
I would say real then.
Complex, imaginary, real.
Yes, that's what it is.
Yeah.
All right, number 3.
Adding complex numbers.
Adding complex. So what are we? Does it want us to add?
Yeah.
Okay. What are your numbers?
-8i plus 4i.
Plus 4i.
Yeah.
Treat these like a variable. So -8 plus 4 is a -4, and attach the I. So you treat the I like a variable when you're adding them. Okay, so Peyton, what's your number 4?
Subtract the complex numbers. 4i minus, parentheses, -3i, close parentheses.
Like that?
Yes.
Okay. Just a little rule in math. There's no such thing as subtraction. Add a line, change the sign.
I'll learn to do this.
So 4 plus 3 is a 7. But it would be the same thing. So if you had like 4i minus 3i, 4 minus 3 is 1. But we make that 1 invisible. It would just be I. So you're just taking the coefficients and adding and subtracting them.
So on 5.
All right, Hunter, what's your number 5?
Determine the conjugate of 3 minus 5i.
3 minus 5i, and it wants the conjugate.
Yes.
All right, see if I can remember how to do this. I want to say the conjugate is, so the conjugate would be 3 plus 5. Oh, it would help if you could see. Let me write that better. 3 plus 5i.
Let's just change the sign.
It's changed the sign, but the reason you do that is when we get to, like, with these infractions, we can use the conjugate to simplify. And so, like, if we do FOIL here, 3 times 3 is 9. 3 times 5i is 15i. 3 times -5i is -15i. And then 5i, or negative 5 times positive 5 is negative 25i squared. So what happens is these cancel, and then I squared is a negative 1. So you would have 9 plus 25. It just helps you eliminate that imaginary number using the properties of imaginary numbers. So that's what the conjugate is used for, just because I have a feeling we're going to have to do that. All right, Shelby,
So what was the final answer?
this one. The conjugate is just flip the sign.
Oh.
It's whatever makes it cancel out.
Oh, that's,
Okay.
Yeah. Whatever value makes it cancel itself out. All right, Shelby, you're number 6.
The division 3 plus 8i over 8 minus 6i is performed by multiplying the numerator and denominator
By the conjugate. So this is where that comes into play. We would multiply this by the conjugate, which would be 8 plus 6i. And that way we eliminate that imaginary number on the bottom.
So it's just 8 plus 6i.
It should be the conjugate of whatever your denominator is. So whatever is on the bottom, you want the conjugate of that.
That's right.
All right, Lexi, what's your number 7?
Fill in the blank says the resulting statement is true.
Okay.
Square root of negative 45
Okay.
equals blank.
Equals blank. Okay.
Square root of 45 equals blank.
Okay.
Square root of 9 times 5 equals blank. And then it just has square root of 5 with no blank.
And then the square root of 5.
Yeah.
Okay. Let's do this one first. Okay. If there's multiplication over there, I can split the radical. I could write this as the square root of 9 times the square root of 5. The square root of 9 is positive negative 3. And then we just attach, you can't simplify this any further. Square root of 5 is just the square root of 5. Okay? Algebra 1 does this. They have to simplify radicals. Is that an option for that one, the 9 times 5 plus minus 3?
You put 8 plus 2.
Yeah.
Huh?
You type it.
Oh, okay.
So how do we do that?
How do you do a plus or minus?
Maybe you put like fraction in front of it and put plus or minus in the fraction.
Be 2. I would say just do 2, or so on yours, I would just do 3 square root of 5 and let's see if that works. Oh, that's what that is. That's what this little piece is. At the end?
Oh, like
Everything
the-
equals that.
Yeah, so you just put a 3 in there.
so we just make it a cube root?
No. It's not making it a cube root. You're simplifying a radical. So like perfect squares, things like the square root of 144. That's a perfect square. You get a nice pretty answer. But if you do the square root of 45, you get this gross answer. So at this level in math, you don't work with decimals anymore. You write exact answers, but in simplified form. And so the square root of 45, how you figure out if you can simplify it is you do the prime factorization. So what two numbers can I multiply together to get a 45? 5 and 9? Okay, so 5 is prime. 9 I can multiply 3 and 3. So I could rewrite this, the square root of 45, as, actually I'm going to write it this way. Or 3 squared times 5. And then I can split that radical. Okay? And so what happens when I split that radical, this radical cancels that exponent and I'm left with just a plain old 3, and then I still have the square root of 5 trapped. That won't simplify any further. Okay, I'll work another one. Give me just a second. I'll pull another example. Okay. So if we know that the square root of 45 is 3 times the square root of 5, then this one, what happens is, so back up here to this, we would write it as 3 squared times 5 times a negative 1. And so when we split that radical apart, 3 squared, 5, square root of negative 1. This is going to cancel and simplify to a 3. Square root of 5 doesn't simplify. The square root of negative 1 is an I. And so when I write this in proper form, I would write 3i square root of 5. Let me see how you're typing answers in at the same time. No, that one would be a 2 there. That would be a 2. This one would be the same answer. This would be 4 times 17 is 68, right?
Back it up.
So that one would be, I think that one should be,
It's everything.
no, that one wouldn't be. I think this one here is just 2 square root 17. And then this one would be 2i. Is it marking them wrong?
Yeah. All of my answers are incorrect.
I'm just trying to show us the steps to get to this.
Oh, so each resulting statement is true. Okay.
So this last one equals.
Okay, I see what, okay. So, hang on before you do your next answer. Give me your numbers, Joseph. So what does yours start off with?
Square root of negative 68.
Square root of negative 68, and then it says equal blank square root of 68, right?
Yes.
So they're pulling the negative out. So that first blank should be
Oh.
an I. Okay, and then what's the next? It's
Equals blank, and the square root of 4 times 17.
4 times 17. So that would still be an I. All they've done is they've broken 68 down into 4 times 17. And then the last one is blank square root of 17, right? So they've split this radical, square root of 4 times the square root of 17. So we've got an I there, but the square root of 4 is 2. So we would have 2i square root of 17. So Joseph, check that before I have them go a second time. Does that work? Okay, anybody else need help with theirs on that one? Because that one's tricky. This should be the same on everybody's. It's just this number right here that's going to change.
Just the way they set it up.
Yeah. It is so hard when I can't see what we're doing. All right, Joseph, what's your number 8?
Number 8, it's parentheses 6 minus 4i plus parentheses 5 plus 3i plus parentheses.
And then it wants you to add those two?
It says write the expression in standard form a plus bi.
Okay, A plus B. I think I know how to do this one, but give me a second to. So, take your two plain numbers. 6 plus 5 gives you 11. And then take your I pieces. Negative 4i, positive 3i gives you a negative 1i, or just negative I. Yeah, always make ones invisible. Never write 1x, anything like that.
And 9's the same way.
Yeah, we're
It's just subtract.
Okay, so Peyton, what's yours?
Number
9.
Both parentheses 8 plus 2i close parentheses.
Okay.
Minus.
Okay.
Both parentheses 9 minus 3i close.
Okay, so what's different here is the subtraction. This gets distributed. So you have 8 plus 2i. That makes that a negative 9. negative 3i makes a positive 3i. So just be really careful with your signs. So 8 and negative 9 makes a negative 1. 2i and 3i makes a 5i. So just be really careful with your signs on ones like that. All right, Hunter, what's your number 10? Which number, baby?
No, I was just looking at 9.
Okay. I can work if you want me to look at.
You said 10?
Yes, baby.
8 minus, open parentheses, negative 6 plus 4i, close parentheses, minus, open parentheses, negative 8 minus I, close parentheses.
Does that look right?
Yeah.
Okay. So, distribute. So 8 minus a negative turns it into a positive, minus a positive turns it into a negative. Minus a negative, minus a negative, combine like terms. So 16, 24?
Yeah.
24, and then negative 4 and positive 1 is a negative.
It's 22.
Oh, 22. Ugh. Minus 3i. Sorry.
Yep.
Okay. All right, Shelby, 11.
9i minus open parentheses 8 minus 5i close parentheses equals.
Okay, just like that?
This one.
Okay. Same thing, distribute. So 9i minus 8 plus 5i. 9 and 5 makes a 14. Okay, but it's not in order, so make sure you're writing them in standard form. So constant should come first, the imaginary number should come last. All right, number 12. Lexi.
Negative 7i, parentheses, 8i minus 3.
So we're multiplying here?
Yes.
Okay. Again, let me.
Starts.
Okay. So if we multiply using distribution, so negative 7 times 8 is a negative 56. I times I is I squared. And then negative 7 times negative 3 is a positive 21, and then we just keep the I piece. I squared is negative 1. So what happens here is the sign changes. We get 56 plus 21i. So you really have to just kind of keep track of your steps and keep track of your pieces and your signs. Anybody else have a different one like that they need help with? All right. Joseph, 13.
13.
Mm-hmm.
Parentheses, negative 9 plus 2i close.
Okay.
Parentheses, 8 plus I close.
8 plus I. Does that look right? Okay. This is a FOIL. Do y'all remember FOIL?
Yeah.
Okay. First, outside, inside, last. So first is the first number in each set of parentheses. So negative 9 times 8 is 72. Negative 72. Outside are the outside parentheses. Negative 9 times I is negative 9i. Inside are the inside two parentheses. So 2i times 8 is 16i. And then last are the last two pieces in the set of parentheses. So 2i times I is 2i squared. So,
Like term.
combine like terms, we get 7i. And then, remember, I squared is a negative 1. So we're going to combine a negative 2 with a negative 72. So negative 74 plus 7i. So just make sure that you're breaking down each piece before you combine. Anybody have a different one on that one that they would like me to work? So we're like halfway through this with this homework. How are you guys feeling about this stuff? We okay? All right. Peyton, 14.
Parentheses, 4 minus 5i.
Okay.
Close parentheses. Another parentheses.
Okay.
Minus 2 minus 8i.
Okay, does that look right?
Yes.
Okay. Foil. So first, 4 times a negative 2 is a negative 8. Outside, 4 times negative 8 is a negative 32. Keep the I. I for inside. Negative 5 times negative 2 is a positive 10. Keep the I. And then last, negative 5 times a negative 8 is a positive 40. I times I squared. All right, so negative 32 and a positive 10 gives me negative 22i. I squared is a negative 1, so that makes a negative. And so I'm just moving it here so I have the like terms grouped together. Negative 40 and negative 8 make a negative 48. How are we doing time-wise?
Yeah, like
17. Yes.
Okay. I think we can do this. What, we've got like
So
8 questions left?
yeah.
Okay.
15 is just same thing.
Okay.
16 it's dividing.
All right, so do y'all want to skip down to 16 and come back to 15 if we have time?
yes.
Okay, so let's skip to 16. And then we'll come back and catch 15 if we have time. Okay. Hunter, what's your 16?
5 divided by 3 minus I.
5 divided by
3 minus I.
3 minus I. Okay, so it's not really division. This is another one I'm going to check, make sure I'm explaining it to you right. Okay, so we're going to multiply by the conjugate. Anything that you do to a fraction, you have to do to the same thing to the top and the bottom.
Try to cancel out, so it would just be
So 5 times 3 is 15.
15 plus I. Or
5
15 plus
times I is 5i. Okay, wait. It's a little bit trickier than just canceling out. So this, when we multiply, we would FOIL, right? But because we're multiplying by the conjugate, we can just do the first and the last. Because it's going to cancel out the outside and the inside.
So would it just be 9?
So 3 times 3 is 9. But then it's going to be negative I times positive I is going to be negative I squared.
So it would just be 9.
It would be 10, right? 9 minus a negative 1 would be a 10.
Right.
Okay. But look, this fraction's not in simplest form.
So then you have to.
Okay,
divide
here's
by
the
5.
easiest way. We're going to split it, and then we're going to put it back together. I'm going to do 15 over 10 and 5i over 10. So you split at addition or subtraction. So 15 is 3 times 5. 10 is 2 times 5. 5i is 5 times I. 10 is 5 times 2. If there's any like terms on the top and the bottom, they cancel out, just with this fraction. Same with this fraction. And then whatever's left is what's remaining. So we've got a 3 here and a 2 on the bottom. We've got an I here and we've got a 2 on the bottom.
It'd be 3i plus 2.
If they have the same denominator, I can write it as one fraction. But that's where those fraction rules and not knowing the fraction rules come back and really hurt you, is not knowing to simplify.
I can go straight.
Yep. Shelby, what's your 17? Okay, is your 17, is it similar to this one?
It's 20i over 3.
Wait, it said 3i plus 2 is incorrect. Or, yeah, 3 plus I over 2 is incorrect.
It's incorrect.
Yeah.
What form does it want it? Does it tell you what form it wants it in?
Although your answer is equal to the correct answer, it is not the correct form. Be sure to read any instructions given by the problem. Make sure your answer is fully simplified.
So next to the answering things.
All it
is
says
simple.
it has to be in standard form.
Okay, so wait.
So,
Somebody else, before he uses his last chance, give me your problem.
That was only my first one.
Oh, you can do it again
Yeah.
and it not count it
I
wrong?
think you have 3 chances. So.
Try this. 3 over 2 plus 1/2 I. And then I'll show you what I did. How I got that. And then I'm going to work, Shelby, I'm going to work your 16 too, just to give another example of how to do this.
So 1/2 I.
Uh-huh.
Alright, that was it.
That worked? Shelby, give me your number 16.
2 over 5 minus I.
2 over 5 minus I. Okay, so I'm going to multiply by the conjugate. 5 plus I, 5 plus I. 2 times 5 is 10. 2 times I is 2I. So 5 times 5 is 25. Negative I times positive I is negative I squared. I squared is a negative 1. So 25 minus a negative 1 is a 26.
I got that.
Okay. Simplify. What do each of these pieces, what's the common factor between 10, 2, and 26? 2. So let's pull a 2 out of everything. So if we pull a 2 out of this, it just cancels, right? If we pull a 2 out of 26, I'm left with a 13. If I pull a 2 out of 10, I'm left with a 5. Same process that I did up here, just explaining it a different way. So what we're left with is 5 plus I over 13, but that's not standard form. So I'm going to split the fraction at the addition sign. I can do that. I can pull a fraction apart like that. So this is good. 5 over 13 is good. But I can also pull the I apart from that fraction. Okay? What's left, I just take the denominator and put a 1 over it. Unless it was like, if there's a coefficient there. If we see one like that, I'll show you too. And then I just smack the I onto the back like a variable.
Alright, so mine is pretty similar.
So that's right. That's the answer.
That should be your answer. Okay, so what's yours, Peyton?
So I have 4 over 5 minus I, so
Okay, so
save some time, we can just double the top of her.
yeah, I'm going to go really quick through it because we know this is going to be 26. Okay. So let's say we simplify by, well, a 2 is all we can simplify by. So that would be a 10, 2I, and then this would be a 13. Okay, so when I pull it apart, I would have 10 over 13. Yeah, this is exactly what I was talking about. Plus 2I over 13, right? So this piece stays the same, but I can pull that I and I can pull that fraction apart. So I can write 2 over 13 as like its own fraction and just smack the I onto the end. So you're just kind of pulling the fraction and the I apart.
Alright.
Okay, Joseph, 17.
17.
Uh-huh.
4i over 1 plus I.
Over 1 plus I.
Yeah.
So we would do 1 minus I, 1 minus I. So we get, so 4I times 1 is 4I. 4I, so again, invisible math here. 4 times negative 1 is a negative 4. I times I is I squared. And then this would be 1 times 1 is 1. Positive I times negative I is negative I squared. My brain just... I squared is a negative 1. 1 minus a negative 1 is a 2. I'm not going to simplify yet because of that. So I squared is a negative 1. And so this would be 4I, negative 4 and a negative 1 is a positive 4. All right, so if we simplify by 2, we get 2I plus 2. But again, standard form, you have to flip it around. 2 plus 2I. Was that right, Joseph?
Check that.
Okay.
Yes.
Okay. Anybody have a different one they'd like me to work on 17? Or do you want me to just to work through? We got 7 minutes. Let's do this. Peyton, give me your number 18. Hunter, be ready with number 19. I'm going to continue this video after you guys leave so I can work at least one example of the rest of these, okay? So Peyton, what's your number 18?
1 plus I over 4 plus 2I.
4 plus 2I. Does that look right?
Yes.
Okay.
It's divide the following complex numbers, express the result in standard form where A and B are fractions in lowest terms.
A and B are fractions in lowest terms. Okay. That's typical. All right, Hunter, what's your 19?
Square root of negative 100 equals.
Okay. Shelby, what's your number 20?
Square root of negative 27.
Square root of negative 27. I may be able to get through those really quick. Lexi, what's your 21? All right, well, she's coming up with that. I'm going to go back up to this one. Or do you have it, Lexi?
It won't load.
Okay. Joseph, what's your 21?
21. Square root of negative 25 minus the square root of negative 36.
Minus the square root of negative 36. Like that?
Yeah.
Okay. Peyton, what's your 22?
7 square roots of negative 9 plus
7 square root negative 9 plus,
3 square roots of negative 25,
like that?
making 9 negative.
Okay, right here?
Yes.
That looks right?
Yes, ma'am.
Okay. Hunter, what's your 23?
Negative 12 plus square root of negative 45 over 24.
Like that? Ooh,
All of it's over 24.
all of it's over 24. So negative 12 plus the negative square root of 45 over 24, like that?
Yes, ma'am.
Simplify. Okay, Shelby, what's your 24?
Negative 3 minus the square root of negative 20.
Wait, minus the square root of negative 20.
Yes,
Okay,
ma'am. Over 24, the whole thing.
over 24. Okay. I'm just going to go right back up here to the top and get through as much as I can.
We have 25 too.
Oh, there is a 25?
Yes, ma'am.
Crap, give it to me. Somebody, I don't care.
Square root of negative 27.
Okay.
Open parentheses. Square root of negative 5.
Wait, square root of negative 5?
Yes, ma'am.
Okay.
Minus the square root of 2. Close parentheses. The parentheses is not behind 5.
Okay, so square root of negative 27, and then the square root of negative 5 minus the square root of 2, close parentheses. Okay. All right, so what I'll do, because that bell, we got 4 minutes, I will record. All right, so let's wrap up these last few here. Oops, sorry. All right, so we would multiply by the conjugate, 4 minus 2i over 4 minus 2i. So now we're going to have to FOIL twice. Okay, so we're going to have to FOIL the top. Sorry, I'm just making sure. Okay, so 1 times 4 is 4. Outside, 1 times negative 2i is negative 2i. Then inside, 4 times I is 4i. And then I times the negative 2i is negative 2i squared. Down here, since we're multiplying by the conjugate, it's going to cancel itself out, okay? So that's why I'm not doing all the FOIL on the bottom, is because I'm multiplying by the conjugate. I know what's going to happen, okay? So if I FOIL this, 4 times 4 is 16, and then outside 4 times negative 2i is negative 8i. 2i times 4 is positive 8i. Positive 2 times a negative 2 is a negative 4i squared. This cancels. So I can just, when I'm multiplying by the conjugate, I can just go 4 times 4 is 16, and then positive 2i times negative 2i is negative 4i squared. Okay? That comes with practice. Okay? So let's see here. We've got 4, and then negative 2i and positive 4i is a positive 2i. And then I squared is a negative 1. So I'm just simplifying just little chunks at a time here. Then I've got 16 minus 4 times a negative 1. So I'm going to simplify again. I'm going to come down here. So 4 plus 2i. Negative 2 and a negative 1 make a positive 2. And then negative 4 times a negative 1 makes a positive 16. Simplify again. 4 plus 2 is 6. Plus the 2i. 16 plus 4 is 20. My common factor here is a 2. Okay? That 2. So I'm going to divide each piece by 2. 6 divided by 2 is a 3. Sorry. It would cancel out here. 20 would be a 10. So when I write this final form, split that fraction, I would have 3 over 10 plus 1/10 I. I'm taking that fraction and I'm pulling it apart, and then I'm pulling it apart again here. These are tough. If you need help with this one, come swing by my classroom 5th, 6th, or 8th if you're having trouble with this one, okay? Or shoot me an email and I'll get you a step-by-step breakdown of the work, okay? All right, 19. This one, since it's got a negative, I'm going to go ahead and split into the square root of 100 times the square root of negative 1. Square root of 100 is a 10. Square root of negative 1 is an I. So that one's easy to break down. Okay, this one, do the same thing. Pull that negative out. Now, square root of 27 is not going to go down that easy. So let's factor that. 27 is 9 times 3. 3 is prime. 9 is 3 times 3. All I want are groups of 2. So I can rewrite square root of 27. There's several ways that I can rewrite this, but I'm going to write it as 3 squared, and then I've got a 3 left over, times 3. And then we already know this is going to be an I. Okay? If I pull this radical apart, okay, this cancels. And so I have, here's where I'm not sure what proper form he wants, okay? I don't know if he wants it like this, or if he wants it like this. Look back through your notes, see if there's one that's worked that way, because I want to say that this is proper form, but I'm just not sure. Okay, so either of these could be the right answer. So I'm just not sure on what form he wants. If you can find an example in the notes, let me know. Okay, 21. I'm going to do this a bit at a time. So this here is going to be the square root of 25 times the square root of negative 1. I'm just going to keep this minus, and I'm going to put all of this in parentheses. Okay, so square root of 36 times the square root of negative 1. So square root of 25 is a 5. Square root of negative 1 is an I. Again, I'm going to keep all this in parentheses. So square root of 36 is a 6. Square root of negative 1 is an I. And then that way I can just make sure that I'm catching that sign. 5I minus 6I. Oh my goodness. Minus 6I. That's a 6. Would be a negative 1I. Or in simplified form, a negative I. Be careful with your signs on that one. Okay, 22. This right here, again, I'm going to do parentheses just to keep everything sorted and then go back and clean it up. So this would be the square root of 9 times the square root of negative 1. This would be the square root of 25 times the square root of negative 1. All right, square root of 9 is a 3. Square root of negative 1 is an I. Square root of 25 is a 5, and that would be an I. Then I can distribute, right? So this would be 21I plus 15I. When combined, I get 36I. So again, those parentheses just kind of help you keep everything neat, tidy, organized where you need it. All right, same thing on these two. I don't know what he's considering simplified form. So if you've got something in your notes that kind of shows you, I'm going to work through this the best way I know how. I'm going to break this down first. Actually, I'm going to pull it apart. Negative 12 over 24 plus the square root of negative 45 over 24. That way I can just knock this piece out. That's a negative 1/2. Okay? This piece is done. We're done with that one. This we have to simplify down. Okay? So we'll come back to this, but let's look at just this piece right here. There's a lot of little things that you have to do. So the first thing I want to do is split this up. Square root of 45 times the square root of negative 1. And then I need to break that 45 down. So 45 is 9 times 5. 5 is prime. 9 is 3 times 3. So square root of 45, here's how I teach Algebra 1. If you find a pair, it gets to come outside the radical. You just write it once. So there's a pair of 3s, so I'm going to write 1 3, single 5. He's got to stay underneath the radical. And then this is going to be an I. Again, this is where the cleaning up, I'm not sure. Okay, so just bear with me here. Now, all I did was simplify this top part. It's still over 24. So if I factor a 3 out of this, right, I can factor this 3 out. I'm going to be left with an 8 down here. So I would have the square root of 5I over 8. That's this piece broken down. Again, I don't know. Man, I don't know how he's going to want this. So if I was going to write this, you got two options here. Negative 1/2 plus the square root of 5 over 8. I think that may be your best option. The only other thing I could think of would be something like this. I'm just not sure what order he wants these two pieces in. So again, that may be a question for your professor for this class, is what they consider simplest form. So on this one, and then this one's the same way. My gut tends to this, but I'm just not sure. Okay, again, look through your notes, see if he writes one out, or she, I don't know what professor we're dealing with here, but find out what the simplest form is on those. All right, 24. I'm gonna split this one as well. So negative 3 over 24, and then it's gonna be minus the square root of negative 20 over 24. So this right here is gonna simplify to a negative 1/8, and then we're gonna have minus, and then whatever this piece is. So 20, let's break down this first. Square root of negative 20, I can write as the square root of 20 and the square root of negative 1. I'm going to break 20 down because I need to simplify that radical. 2 times 10, 2 is prime. 10 is 2 times 5, 2 is prime, 5 is prime. So this I can rewrite. So there's my pair. And then this would be the I. And then that's still over 24. So we would have over 24. If we factor out the 2, we'd be left with a 12. So we would have, and again, I just don't know what form he wants. It may be like this. So y'all please find that out. So this is going to be minus I square root of 5 over 12. That's my best guess. If it's the other way, it would be like this. Okay, so please find out what he considers simplest form. Okay, last one here. We're going to break each piece down individually, and then we'll put it all back together. So the square root of negative 27, we've already done that, but would be the square root of 27 times the square root of negative 1. 27, remember, is 3 times 9. 3 times 3 is 3 times the square root of 3i. Okay, so that's this piece. And I'm going to write it this way, 3i square root of 3. Because I really do think that's right. All right, square root of negative 5 is the square root of 5 times the square root of negative 1, which would just be I times the square root of 5. Minus, and then I'm going to put, that's going to be in parentheses here so I can make sure that I distribute it right. Oh, square root of 2 doesn't break down any further. So it is just going to be negative square root of 2. And then we got to multiply this piece times this piece. Okay. Distribute, right? So 3i times I would be 3i squared. Square root of 3 times the square root of 5 is the square root of 15. Okay? You can multiply what's underneath those radicals together. It's the opposite of what we're doing here. We're putting it back is what we're doing. And so then this one would be, again, there's an invisible 1 here, so negative 3i, and then square root of 3 times square root of 2 is square root of 6. I squared is a negative 1. So that would be a negative 3 times the square root of 15 minus 3i square root of 6. Again, please check with your professor. Find out which way he wants these. If he wants 3 square root of 6 and then the I at the end. See how he's wanting those in simplest form.